Hello, everybody, and welcome to Cloud Engineering Days 2022. Super excited to have you here today. We're actually doing this live today, believe it or not, from Seattle, Washington. My name's Joe Duffy. I'm the founder and CEO of Pulumi, and I'm joined with Luke Hoban, our CTO. And today we're going to go through a bit of an update on Pulumi, what we've been up to, what we've been building. We're also going to talk about some exciting customer stories. We're going to hear from several key customers of ours. And we're going to cap it all off with some fun new launches that are available starting right now. So let's dive straight in. You know, I think earlier this year, for folks who might have missed it, we actually hit our 5-year anniversary as a company, which is really exciting. I can't believe we've been on this journey that long. You know, started in 2017 and really launched great open source technology with our flagship infrastructure as code in June of 2018. Followed pretty shortly thereafter with Pulumi 1.0. You know, we heard from a lot of enterprise customers that stability and having that 1.0 promise of no breaking changes and having a stable foundation for your infrastructure was very important. So that was a key milestone for all of us as a company. The Pulumi 2.0 wave of innovation was more around sort of adjacencies, you know, things like policy as code, the ability to test your infrastructure as code, the ability to ship your infrastructure in CI/CD. Pulumi 3.0 and Universal introduced some additional languages with, you know, C# and the rest of the .NET family, Java, more recently YAML, and we'll talk a little bit about that later today. So just continuous steady drumbeat of innovation year over year. Pulumi is also open source. You know, everything is about community for us here at Pulumi. And we've seen a huge increase in just contributions across the board, recently hitting 14,000 GitHub stars, almost 3,000 contributors to the core Pulumi open source project. And for us, again, we lead with community because what we see is as that community grows, the community helps other community members with education and content. And there's just sort of a network effect that kicks in at a certain scale. So for us, we love seeing all of these metrics up and to the right. Also been seeing great community momentum in general in terms of users of Pulumi and customers and the depth of usage. We recently surpassed 100,000 community members that we've touched with the Pulumi story. We've seen just over 1,000 customers becoming a commercial relationship with us, where it's a great partnership and we can help them in their journey to the cloud. And we've seen an increase in depth of usage as well. You know, our North Star metric is resources under management. For every one of those is a live resource in AWS or Azure, Kubernetes, Google Cloud, any of our 100 plus partners that we have providers for. Every one of those is a live resource. And so as we see that increasing, recently surpassing 5 million, that tells us a lot about the depth of usage. There's just a lot more resources being managed. The complexity of environments is increasing. There are more projects. And so we love seeing that, that metric growing as well. It tells us that customers are being successful with Pulumi. And I mentioned over 100 different cloud providers in our registry now. And, you know, here's a sort of a snapshot of some of the key ones from obviously the major clouds, AWS, Microsoft, Google Cloud, the CNCF with great Kubernetes support and Helm, but also folks like Cloudflare and Kong and DigitalOcean and Datadog. These all are providers of infrastructure. And although many times we think of infrastructure as code, we think about the major clouds and we think about things like managing serverless applications. The reality is all these other providers offer infrastructure as a service as well in various forms. And all of that needs to be managed very much like the major cloud resources. So it's been great to partner with these folks, with lots of shared customers together. We're frequently doing workshops and helping each other's mutual customers be successful. And for Pulumi, we're all about just making all of these different platforms as accessible and as easy to use as possible. I mentioned the customer momentum. It's really amazing. You're going to hear some great stories from some of these key customers today with Panther Labs and Altana, Dutchy, and others. And I think the key theme here, you'll notice that there's, you know, a lot of different variety of customers here, from small customers, early stage startups like ChainGuard, all the way up to some of the largest organizations in the world like Mercedes-Benz. I think the key trend here is customers are picking Pulumi because it gives them a competitive advantage in the cloud. They can move a lot faster, they can get more done with less. and empower developers while doing so. And we'll hear a little bit more about that part of the story in the customer's own words later on. But really amazing to crack the 1,000 customer count just recently, and really we're only just getting started. So taking a step back, let's talk a little bit about the founding story of Pulumi. What was the vision of the company? What are we trying to do? Why are we here? And that will set the stage for some of the new announcements that we'll then jump into. And I'll sort of get out of the way and let Luke show some cool demos and jump into code very shortly. I think our observation with Pulumi was that the modern cloud really changes everything about software development. You think about 20 years ago, we were building simple client server applications. There was a hard divide between the infrastructure side of the team, the operations side of the team, and the developers. Developers could easily write simple 3-tier applications and then file a ticket, get some infrastructure, and then have the infrastructure team sort of install it into virtual machines and manage it. But the modern cloud is so different from that. We're shipping daily, multiple times a day in many cases, not once a month or even once a week. The pace of innovation is just so much greater. The complexity of the cloud is also so much greater. You think of, we've gone from a world of 2 virtual machines and a database to a world of hundreds, sometimes thousands of moving pieces in a single project. And that's because, AWS, for example, and many of the cloud providers provide these rich building block services that we can stitch together in infinite ways to create new solutions. And although it's changed everything, it hadn't changed very much in terms of the fundamental software development lifecycle. We still find that many times developers struggle to make the most out of the cloud. We find that infrastructure teams are maybe not working with tools that are helping them scale and deal with the complexity of the modern cloud. And so at Pulumi, we took a step back. We said, hey, we're fundamentally entering a new era. That era is the modern cloud era. And it's an era of real distributed application architectures. The cloud isn't an afterthought anymore. It's really part of the core fabric of how we build modern software. And that's really exciting. You look at some of the most innovative companies, 5 years ago when we started, we'd say, Airbnb, Lyft, Spotify, these companies that are really disrupting entire industries thanks to the cloud. And since then, we've just seen an acceleration of that. The cloud is touching every one of our businesses in a key way. And so our new reality that we realized was that all software is cloud software. Every application we're building these days is touched by the cloud in one way or another. Maybe it's we're using a data lake. Maybe we're using AI services. Maybe it's a serverless application that needs to be broken apart into lots of little pieces. Maybe it's a containerized microservice where I need to think about service discovery and how to connect to other bits of services and software that my team is building. If you believe that, which we very much do at Pulumi, that means all developers are cloud developers, and that's really exciting. It means developers can really think of the cloud as really a superpower, that if they can just harness that, they can build increasingly powerful capabilities into the applications they're building and really transform the business. And that's the final point here, is that infrastructure enables this new way of building. Infrastructure enables innovation. It's no longer a tax, an afterthought, or a cost center. It's really central to how the entire organization operates. And so at Pulumi, we like to say we're here to democratize the cloud. And by that, we mean make the cloud as accessible as possible to as many builders out there in the world as possible. So we started with infrastructure as code. That's our flagship technology. We've since launched a lot of new capabilities. You'll see some new ones today, but really that's what we're all about, is infrastructure as code. And why is that? Well, infrastructure as code gives us this programmable surface area over the modern cloud. It gives us all of those cloud providers that we saw earlier, and it allows us to program them. We sometimes say program the cloud. It's sort of our, Nike just do it is here at Pulumi. And why is that important? Well, as we want to build bigger experiences out of smaller things, we need some composable, programmable model that understands resource lifetime in the cloud. And that's what Pulumi Infrastructure as Code gives us. But we took a different approach to infrastructure as code. We like to say universal. And by that, we mean we wanted to support all the different cloud providers that we saw earlier. We wanted to support every language as well. So when I think of infrastructure as code, there's really two key parts. There's the expression language, and then there's the execution engine, the thing that understands how to do declarative infrastructure as code. With Pulumi, we said, bring your favorite language for the expression part, and we'll marry that with great declarative infrastructure as code. And so you get your choice of language as well. We know that developers are increasingly getting into the driver's seat when it comes to cloud infrastructure, so we wanted to support developers. But we also see that infrastructure teams had burning needs as well that we could solve with this approach. And so we really wanted to bring the same solution to the entire team and really break down some of those barriers. Every architecture, when we started, we saw that there were many people trying to solve the problem just for containers or just for serverless, and oftentimes forgetting the fact that we have many workloads still running in virtual machines. And so Pulumi took an approach of supporting every architecture with one common approach and all of the cloud resources that go into those architectures. So we like to say your cloud, your language, your way. If you look at the languages we support, any Node.js language, JavaScript, TypeScript, Python, any .NET language, so C# or F#. We support Go, great for distributed systems. We've recently launched support for Java earlier this year, and it's not just Java, it's any JVM language, so Scala, Kotlin, Clojure, Groovy. We launched YAML support earlier this year, and we've got some exciting news today about that for when the simple things are simple. YAML is a fine solution, and because of that, we were able to bring Q into the ecosystem as well. An important thing about the languages is it's not just the language itself. Of course, it's great that you get for loops and if statements. It's funny how many times we hear people coming from other infrastructure as code tools say, hey, the killer feature was that I actually just get a for loop, which we can easily take for granted, but it is very powerful to have that capability combined with declarative infrastructure as code. But you get the whole ecosystem around the language as well. You get great editors and IDEs, refactoring support, test frameworks, static analysis tools, package managers, so we can actually codify best practices and share and reuse them. It's not just the language, it's the whole ecosystem around it. And by the way, great Stack Overflow support, community support, people graduating from college know a lot of these languages. It's a great ecosystem to be able to tap into. I already mentioned all these different cloud providers. We expose the entirety of each one of them in its raw form so that you have full access to all of the features and functionality in all these different cloud providers. And then we want to meet folks where they are. So if you are already using GitHub Actions to do application deployments, you can now easily plug Pulumi in and do the same for infrastructure deployments. Or Spinnaker, Azure Pipelines, any of these supported providers. And then, of course, we integrate with your identity provider of choice so that you get full integration across all of your toolchain. An important point that I'll pause, and I've sort of made this point already, but it's an important point that's easy to miss, is Pulumi's approach gives you the flexibility of languages, which sometimes those languages are imperative, sometimes they're functional, sometimes they're declarative, as in the case with YAML. But it takes all of the things we know and love about those and marries that with everything we know and love about declarative infrastructure as code. This is why I mentioned the expression language is different from the execution engine itself. What this means is you get all the benefits of infrastructure as code. You can preview changes before you make them. You can easily do CI/CD. You get full change history of who made what change to what resource when. You can automate the workflows. You can enforce security and compliance and best practices. So it's really the best of both worlds. And that's what Pulumi sort of brought to the table with our initial flagship infrastructure as code technology. That allows us to go from manual steps and markup languages. How many of us have found ourselves, wading in 6,000 lines of YAML to set up an Amazon VPC? That was a very common problem for many of us. But now we get to go beyond that to build in best practices. So this is an example of spinning up a EKS cluster in Amazon. And yes, it's really that simple, just a few lines of code in whichever language you'd like to use. And we're going to see that in action in just a minute, along with a bunch of new features that we're happy to launch today, which is Pulumi Architecture Templates is the first one, which make it really easy to get started with infrastructure as code. What we heard from users was, hey, there's 80% of the scenarios where all I wanted was to start with a microservice, serverless app, static website, VM, Kubernetes cluster, et cetera. on AWS or Azure or Google Cloud or Kubernetes. And so we took those common patterns, and we now have these architecture templates that are available to get started much more easily. We've improved our Kubernetes support pretty dramatically by redoing a lot of the architecture of our Kubernetes operator to bring GitOps style of deployments to the forefront of our Kubernetes support. We've actually integrated with the CNCF Flux project. So really great things to do there if you want Kubernetes control plane to be the center of your universe. Easy to support that with Pulumi Infrastructure as Code. And we've also introduced support for server-side apply. Pulumi YAML is now GA, so we've actually taken a lot of the feedback from our early preview this year, addressed the feedback, really improved the support there. And then project level and typed config, which I think you'll see in the demo momentarily, but this really helps to manage complex projects at scale, and it's really a core feature that is going to be useful for any Pulumi Infrastructure as Code project. And with that, I'm going to hand it over to Luke to demonstrate some of this new functionality. Take it away, Luke.
Awesome. Well, thanks, Joe. It's great to be here to get a chance to give a tour of Pulumi's Universal Infrastructure as Code platform. I think you'll need to stop sharing so I can share mine. There we go. Alrighty, so let's get started. And I'm going to start just on the Pulumi homepage here. So here we are on Pulumi.com. And one of the things that we've really invested in pretty heavily over the last few years has been developing a whole lot of different learning resources to enable teams and individuals to sort of get up to speed on infrastructure as code, on how to apply infrastructure as code to the problems that they want to work on. As Joe mentioned, one of the things we've introduced recently is a new set of Pulumi templates. And so these Pulumi templates, we've expanded from just a blank application that we have today for our templates to now it's these architecture templates, things that take common patterns that we've seen many of our Pulumi users look for as they get started with Pulumi, making those available out of the box. And so as Joe mentioned, things like containerized services, serverless applications, static websites, virtual machines, Kubernetes applications, and Kubernetes clusters. And each of these templates is available across all of the different clouds we support, AWS, Azure, and Google Cloud, as well as Kubernetes for the ones that for that applies, as well as all the different languages we support. And so, for example, we can come in here, look at the AWS serverless application, and get an overview of what the architecture is, some details of that, and how to configure it. I'm going to just go ahead and get started with this here. Let's come into our terminal. I'll actually just clean up let's just go ahead and do this. Make sure we don't have something already here. Okay, good. So we've got, we're in this the folder here. What we'll do is we'll type Pulumi new to go and create one of these templates. We can see when we type Pulumi new, we see all the different templates that are available for Pulumi. And this includes more than 100 templates. I think 203 templates are shown here. And I can do something like look for those serverless templates that we just saw on the website. And so for serverless, we see we've got these for AWS, Azure, and GCP, and for all the languages we support. Now, as Joe talked about, we support a variety of sort of existing well-known languages like TypeScript, Python, Go, and C# to enable you to use all the richness of the languages you're familiar with along with your cloud infrastructure. But as we also introduced last spring, support for YAML. And I'm going to show that off and show off some of the things we've done as part of the YAML GA. So let me just accept all the defaults in this Pulumi new prompt. And there we go, we've created our project. And I'll just open this up inside my IDE. So we can see that in this case, we are using the YAML version of this template. And each one of these templates is designed to be a fairly small program, in this case, about 40 lines of code that has an out-of-the-box working example that puts together the building blocks that we need for a simple serverless use case and gives me something working that I can start with and then iterate on from there. In this particular example, we see that Pulumi's YAML format allows me to specify that my runtime is YAML instead of Node.js or Python or Go. And if I do specify YAML, instead of me providing my program in separate files in that other language, I can instead provide my resources and my outputs directly in line inside my Pulumi YAML file. So resources and outputs. In this case, we just have 3 resources, an AWS IAM role, an AWS Lambda function, and a component, which makes it really easy to work with AWS API gateways, REST APIs. Now, Pulumi's YAML format allows me to do simple things like reference the result of this role that was created, grab its ARN, and use that as the input to our function. And similarly, to pass that function as an input into the REST API's handler. So we can do simple things that compose together infrastructure and have access to all of Pulumi's programming model. Let me open up a terminal, and I'll just see what it looks like to deploy this application. So we can type Pulumi up to deploy this into the cloud. We'll see that, as usual, Pulumi up starts by showing me a preview of what's going to happen when I deploy my application. And so in this case, we see sort of what we expect, those three resources we just talked about. But we notice as well that this REST API, as I mentioned, is actually a component. It's a component that puts together a variety of other building block pieces to make it really easy to deploy a REST API. And so in this case, we see that's an S3 bucket, a bucket object, some role policy attachments, some permissions to allow the API gateway to access the function, and a variety of other components. Now, stitching these all together yourself and copy pasting this around is maybe the normal thing that gets done in infrastructure as code. But with Pulumi, we make it really easy to build these reusable abstractions and take advantage of them in other components. And so in this case, this abstraction, this REST API abstraction was actually built using TypeScript, using all the rich capabilities of Pulumi's TypeScript support. But once we've built that and made it into a simple component, we can now use it from YAML and have a simple interface to this component. Let me go ahead and say yes to deploy this. And one of the things you'll immediately see is that we recently added some really nice features to the CLI display. And so, for example, here we see the progress indicators telling me how long it's taken to deploy each one of these resources, so that I can see which pieces of my infrastructure take the most time and how the parallelism is allowing me to deploy various pieces of this at the same time. And so while this is running, it'll just take about 30 seconds, but we'll take a look at a few other features of the Pulumi YAML that's now available in GA. So one is that we've actually introduced IDE support. And so while other languages for Pulumi get IDE support sort of for free, because there's amazing Python support and amazing TypeScript support and Go support inside most IDE environments, Pulumi YAML, we wanted to introduce more support than you get out of the box from just a raw YAML format. And so we added a Pulumi language server protocol for Pulumi and have extensions available in VS Code and Emacs to go and use that. And for example, we can see things like if I hover over the REST API here, I get help text that shows me all of the information about this REST API from our Pulumi registry. We also see that if we make a mistake in our code and have a typo, we get that feedback immediately that this property was named incorrectly. And similarly, if we reference a resource that doesn't exist, like I reference role and RLE instead of role, I get that feedback immediately. And so getting some of these benefits of IDE integration and productivity, even for this simple Pulumi YAML support. Okay, so this was deployed in about 37 seconds. We can go ahead and open this up. And we'll see that this is just a simple static website, but the static website is now calling into a function here that's running in Python. And so that's the simple website here that we're serving, and this simple function handler that we're running to compute the date and return it back to the code. Okay, so that's a simple example of using Pulumi's YAML support. Now, one thing I should also mention, just a nice CLI benefit here. Oops. If I come over here and type Pulumi up again, after I make a small change, we'll see that this actually shows me, because we're using desired state infrastructure as code, we're going to see just the diff that's going to happen here. And so just this function is changing and only its runtime property. But the really nice benefit we got here from some recent work was that we have a much nicer display of some of these diffs. And so, for example, when the runtime changed, we see this really clear indication that the only part that changed was that last digit. And this is especially useful for large and complex strings where it may be hard to identify where the change is, or for YAML or JSON literals that may be encoded as strings, and we might want to be able to understand where exactly the changes were happening. So some nice improvements to just the day-to-day experience using the Pulumi CLI. Okay, so we've talked about YAML here, but one of the really important things about our Pulumi YAML support is that you can start with YAML and still scale up into the full breadth of what's available in the Pulumi platform. And so you can do that by using the Pulumi convert command. And so what I can type is I can say Pulumi convert and then pick a language. And this will take my existing application that I've written here in Pulumi and already deployed and have running. And it'll actually convert it into another supported Pulumi language. And so in this case, we've turned our application into Python. And so there's two things that happened as part of that. The first was that we actually removed all of that code that described this application inside the YAML file itself and we changed the runtime to be Python. And then we came over here and actually created a main.py file that has the exact same resources with the exact same properties, defining the exact same application. I'm going to make one simple change here just to make it a little bit easier to get all of our Python dependencies. Oops. This will mean that we can automatically have Pulumi acquire our virtual environment and dependencies. And then there's just one small change I'll make to the generated code. And so if I now run Pulumi up, what we'll see is that we're now deploying this Python version of the code, but we're deploying it to the same stack that we already had deployed. And so after this goes and acquires all the Python dependencies, we should see that it'll say that there's no diff required and that we can continue building this application now in Python. Give it a second to download some Python dependencies. Okay, and there we go. 12 resources unchanged. We're able to continue moving on from here and evolve our application using Python now. Now, of course, using Python means we get access to a bunch of additional features. And some of those features are like the ability to use classes and build reusable components. And for example, here, we can see that we actually get some autocomplete. This is because I have GitHub's Copilot turned on. And so I'm able to actually get these AI-driven recommendations for how to write my code. And so here I can create a component resource in Pulumi, and GitHub Copilot will actually even tell me sort of what it thinks my component might look like and give me some hints about how to create a reusable component built out of an S3 bucket and some other resources. And so these are the kind of features that we can get for free because we're building on top of a software ecosystem like the Python ecosystem that has so much rich support, including support from tools like GitHub Copilot. Okay, so we won't actually go and build that right now, but that was a quick example of that. But even with this example has still been fairly small and simple just to highlight some of these basic aspects of Pulumi. But let's jump over to a much more complex example to get a feel for what Pulumi looks like at real scale, that real teams are working with today. And so in this particular example, we're looking at a multi-stack project. And so this is two projects. One is a EKS-based infrastructure layer that's going to deploy managed Kubernetes on AWS with some supporting infrastructure. And then we also have a guestbook application, which is going to be an application we want to deploy into our Kubernetes cluster using Kubernetes resources. Now we can see that in this case, we're authoring this in C#, and we're taking advantage of lots of capabilities of the fact that we have a full programming language here. And so, for example, we're able to take advantage of things like for loops. We're able to take advantage of strong typing. So if we get the type of one of these things wrong or get one of the properties wrong, we'll get that feedback immediately. We get IntelliSense and all the features we expect from as a .NET developer. And then finally, we get support for first-class secrets. And so Pulumi's built-in support for secrets ensures that this kube config, which may have some sensitive data in it, we can mark it as secret and make sure that that sensitive data doesn't leak out into any other part of my system. Once we've deployed our base infrastructure layer, we can now work with actually, there's one more thing I wanted to mention there. As well as actually defining this code once, we actually also have 3 stacks. And so we have a development environment, a staging environment, and even a per developer environment, which lets me, for each developer on my team, stand up an individual environment that developer can work with. And one of the things that we can do in Pulumi is once we have infrastructure as code, we can stand up the same program in multiple instances. But each one of those instances may want to have some slightly different configuration. And today, what we find is that we typically have to sort of copy paste some of this configuration between those different stacks. For example, if I want the AWS region to be set, you notice that we're setting that across each one of these stacks to the exact same value. And so one of the features that we've released today is actually support for adding configuration to the project file. And so in this case, instead of me adding it to one of my individual stacks, I can define that I want my AWS region to be US West 2. And I can do that just once in my project file and then remove it from each one of these stacks. And so now I don't have to repeat myself and copy paste, and I can have configuration that lives in one place and is also copied and is inherited into all the projects. I can also be more explicit and say, I just want that to be the default. And I can also say things like, I want the type of this to be a string, or I want the description to be something helpful. And this will allow the Pulumi CLI to provide more guidance and more help for users as they configure new stacks and new instances of the application. So some nice improvements to configuration and projects. But now let's look at Kubernetes itself. So this example is deploying, as I mentioned, a simple Kubernetes-based application onto my cluster. And we'll see that this uses a couple of things. it uses raw Kubernetes resources. So in this case, a Kubernetes core v1 namespace, which is an exact one-to-one mapping of the Kubernetes resource model's namespace object. And I can deploy one of those into my Kubernetes cluster. But then we also see that we're taking our application and deploying it using these three pieces of code, which are each one creating a service deployment component, which is a simple abstraction over the raw Kubernetes service and deployment objects, which lets me just specify what namespace, what image, what ports, and optionally, whether I want a load balance service to be exposed. With this component, I can reduce a lot of the boilerplate of managing Kubernetes resources, but still work with the full capabilities of the Kubernetes platform underneath the hood. And so in this case, each one of this component is something that I actually built as a reusable component. And even though I have access to it here from my .NET program, I'll actually see that it's defined below inside this multi-language package. And it actually happens to be implemented in Go. And so here we can see the implementation of that component. Now, the one last thing I want to mention just before wrapping this up is one other nice enhancement we've made to our Kubernetes support. Although Pulumi's Kubernetes support has been sort of the best-in-class option for applying infrastructure as code to the Kubernetes platform for some time, one of the things we did recently was sort of take that further with support for server-side apply and patch resources. And so we can now create namespace objects in another way as well. So we can say, new k8s.core.v1.namespace. But instead of me just saying namespace, I can also say namespace patch. And so for every resource that we support inside the Kubernetes platform, we now support a patch version of that resource, which allows you to not just create a new resource that's managed by Pulumi, but to actually make edits to existing resources that are defined inside the Kubernetes cluster, that we want to manage those edits with Pulumi, but not the full resource. And this allows you, for example, to add tags to resources, to add values into a config map, lots of different scenarios where typical Kubernetes use cases require you to be able to patch existing objects instead of create new ones. And so with this patch support, we actually have really rich capability to sort of get the best of both worlds of Pulumi's desired state infrastructure as code and the Kubernetes control plane model. And so lots of interesting things there around our Kubernetes platform. So that's it for this first demo, a quick tour of Pulumi's modern infrastructure as code platform and some of the new features that we have been able to deliver. Let me hand it back to Joe.
Perfect. All right. Back in business. So we saw some really cool things there. Honestly, the ability to start with YAML, and then as you hit complexity, just run Pulumi convert and inject into whatever your destination language is, and just run from there is just really mind blowing. And I think the architecture templates are really going to help folks get up and running much more quickly. We saw that rich support across a lot of different common scenarios across every single language. That was something that I think we all take for granted now with Pulumi, that every one of these is now available in all of those 7 different languages that we support. The deeper and richer support for Kubernetes, we definitely see that a lot of folks are using Pulumi for infrastructure as code with Kubernetes. Folks that are all in on sort of cloud native really want to do that more Kubernetes centric GitOps style of deployments. And so all of this stuff is available in the open source project as of today. And yeah, YAML, I think, when we launched YAML, a lot of folks were kind of confused. Hey, isn't Pulumi the anti-YAML company? It's all about, languages. And, it turns out the L in YAML stands for language. For us, what we want to enable is the right tool for the right job. And, sometimes YAML for very simple use cases, as we saw, the starting template that Luke showed, is the right solution. And honestly, YAML is also easier to build tools around sometimes. If you're doing something that's, generating YAML, it's easier to generate a bit of YAML than it is maybe some properly parsable Python, for example. It's definitely much more machine friendly of a format. And frankly, some folks who are coming from a background that may not have as much experience with programming languages, it may be less intimidating to start with YAML and an easier solution. And so honestly, come one, come all, we're all about, supporting every language out there in the ecosystem. And so really excited that YAML is available as GA today as another tool in the tool belt. And typed config, this is something that's going to really help manage configuration at scale. We find, it's a very different ball game to go from managing, 1, 2, or 3 stacks to managing 100 or 200 stacks, which really can't happen. Here at Pulumi, we actually use Pulumi to build the SaaS product that many of you use on a daily basis. And every developer on the team has their own private developer stack. We've got multiple staging environments and test environments, and managing at scale, these sorts of features are a big deal to managing that complexity. So let's move on to the next segment of today's announcements, which is, even though Pulumi gives you these great foundations, we still find that infrastructure is often still a bottleneck. We find that developers are not empowered, and infrastructure teams can really start feeling burnt out because they're really the ones carrying a lot of the burden, a lot of the load in this modern cloud era to take the responsibility of making sure infrastructure is reliable, robust, correct, and able to keep up with the increasing demands of the business. And so Pulumi really does give us these great building blocks, these great programmable foundations with infrastructure as code to be able to empower developers with guardrails like policy as code and built-in best practices, and really level up our game and ship infrastructure faster. And many of you out there, honestly, 80+% of our largest customers use this automation API capability. We shipped this a little over 2 years ago, initially in preview, and last year we hit GA on this. It's been one of the most highly adopted features. It's sort of Pulumi's best kept secret, to be honest. And the idea behind the automation API was, what if infrastructure as code was a library in your favorite language and not just a command line tool? What that does is enables you to really embed infrastructure as code as a capability into a larger software system, enabling advanced automation. We see incredible scenarios like complex deployment orchestration. Maybe you have multi-stack deployment workflows, or maybe you want to do sort of some canary deployment and then scale that up over a period of time. Maybe blue-green deployments, self-serve portals. Many folks out there really want to enable their developers to log into a portal, click a button, and get a microservice environment, for example. Custom tools and frameworks. We've actually seen entire companies and open source projects built on top of the automation API. In fact, Cockroach Labs is an amazing customer of ours. When you log into their SaaS product and you click a button to spin up a Cockroach database as a service, in the back end, it's actually spinning up Kubernetes clusters across AWS and Google Cloud and managing that software using the automation API. So incredible capabilities, really advanced scenarios. An interesting piece of data that we discovered recently is that organizations that are currently today using automation API are able to manage 10 times more infrastructure per engineer than the typical CLI-driven approach. And it makes sense because the software is doing the automation instead of human beings having to run a tool. But it's just an example of a piece of data that demonstrates the incredible scale and capabilities that the automation API has given us. And remember, Pulumi is not just the open source project. Pulumi has the Pulumi service, which adds all of these adjacent capabilities like policy as code, identity, CI/CD integrations, to really give you that cloud engineering platform built on top of our flagship infrastructure as code technology. Pulumi is open source, and you can use Pulumi without using the Pulumi service. We find that 2/3 of our community elect to use it with the service just because it's so much easier. An analogy I draw sometimes is, just as you can use Git offline, it's so much easier to use with GitHub or GitLab. But Pulumi is fully open source. You can use it for free, and manage your own stacks and state files in S3 or Azure blob storage or Google Cloud object storage. And the community is growing fast, as we talked about earlier. But Pulumi service really is the best-in-class way to get security, reliability, ease of use out of the box. And we've continued to improve the functionality available in the service. In fact, we're excited to announce some really key new capabilities today. And that's something called Pulumi Deployments. So Pulumi Deployments is available as of this morning. It's in preview. And what Pulumi Deployments is a deployments as a service technology. It takes everything we learned about automation API and the scenarios that unlocks and enables, and makes that available as a service. That enables some key features like click to deploy. You can now log into the Pulumi console, click a button, and trigger a deployment. You can rotate your AWS credentials in the UI and click a button to redeploy those changes without having to go make any code changes or manually run a CLI, for example. You get great, rich observability for those deployments with logs, deployment history, and full integration with the Pulumi identity and policy systems. So that's one example. You also can click to refresh your stack, destroy your stack, anything to do with a Pulumi deployment action, you can now trigger from the UI. The second key scenario it enables is Git push to deploy. And what that is out-of-the-box GitOps support. Of course, we still support over a dozen different CI/CD providers, and you can still use those just as you could previously. This is all additive beyond everything you could do previously. But what Git push to deploy gives you is out-of-the-box support today on GitHub, and in the future, GitLab and Bitbucket support will be coming. You can open a pull request, get that pull request automatically, have a preview, enlighten the pull request with what changes will happen when you click that merge button, so you can actually do a full code review of the infrastructure changes and the impact of that deployment. When you click the merge button, Pulumi automatically is going to make that deployment happen. And again, this is really taking our lessons learned from Automation API to the next level. In fact, all of this, even though these two key scenarios are available out of the box on day one, this unlocks a ton of new scenarios. Drift detection and remediation, ephemeral stack environments, automatic time bomb stacks. Everything is exposed through a rich REST API where you can build custom tools, custom workflows yourself. In fact, we've added remote deployment support to the Automation API itself. So Pulumi Deployments is actually built on top of Automation API. And now you can program Pulumi deployments from the Automation API, which is going to use the Automation API. So a lot of inception, really exciting things going on there. And with that, I'm going to hand it back to Luke to give a demo of what deployments looks like in action.
Excellent. Well, I'm especially excited to get a chance to show off some of what we're doing with the Pulumi service and Pulumi deployments. So let me just switch over into my browser here. So like Joe mentioned, all of this is sort of capabilities that are enabled through the Pulumi service. And so let's start here in the Pulumi service console. The Pulumi service offers an end-to-end management experience for infrastructure as code using Pulumi. And earlier this summer, we actually made a pretty big overhaul to some of the sort of core UX for the console. And that included moving our navigation over onto the left, having a much richer kind of dashboard here with a lot of access to latest stack updates and resource count over time. And my personal favorite new feature here was the support for favorites. So the ability to mark a subset of my stacks as favorites using this little star right here. And now getting access to those from anywhere I am within my experience using the Pulumi service. And so these features just really help to give me access to the things I care about most when I care about them and be able to navigate easily throughout the console. So let me drive into one of these stacks in particular, one of my favorites here, which is this serverless app stack, serverless app/dev stack. Now, this stack is an instance of that same application, that same template that I showed you in the first demo. And so we can see here, for example, that the outputs, this is running, looks like the application stopped running. So I will not try to run it. I think we have some stuff that cleans up our resources in our development sandbox. So it looks like that maybe happened here. But I can still come over to the stack and look at all the information about the stack here. Now, one of the things that we've had for a long time is integration with lots of different CI services. And one of the reasons why we really want to integrate with whatever continuous delivery option platform you use is because we know that to sort of fully get the benefits of infrastructure as code, we want to automate the delivery of those infrastructure changes. And so we have partnered with all of these providers to make it really easy to integrate with them. But with Pulumi Deploy, we've also made it really easy to go and just do this directly from within Pulumi itself. And so we've added this new Deploy tab here. And the Pulumi Deployments tab allows me to configure how I will actually take actions inside the Pulumi service to deploy my infrastructure. And so in this case, we'll see I'm looking at this Luke Hoban /CED 2022 repo, the main branch, and the serverless app folder. And so let me just go over to that repo here. We've got our repo and our folder called serverless app. And here's the code that we're actually deploying. And so I've set this up. I've also configured some environment variables so that I can have access to AWS resources. And then after I set this all up, you'll notice that there's this new button here that wasn't available previously that lets me take actions on this stack now that I know where its source code lives and how to go and deploy it. And so with this button, we can now create an update, a preview, a refresh, or a destroy for my stack. And each one of these will actually run inside Pulumi's cloud service. And so when we click the button to run a preview, we'll actually see we come over here and start running a preview of a Pulumi deployment from within the Pulumi service. Now, traditionally, this was something I would have run on my local machine, and my laptop or my desktop, or I'd run inside a CI service. But here we can see that now Pulumi is actually able to run these deployments itself. And this allows Pulumi to take action on my behalf in lots of interesting ways. In this case, just by clicking a button, but we'll see later some of the other ways we can wire this up. So as this progresses, we'll see eventually the Pulumi operation, this Pulumi preview, is running. And as soon as that started running, we saw that a sort of a standard preview was displayed here. And so in just a second, this will complete, and we'll actually see that the Pulumi preview indicates that it completed. We'll just jump over here and watch this maybe. Let's just go back into our deployment. So this deployment is running. Should finish in just a second here. Okay, the preview succeeded in just a few seconds. So there we go. We ran a Pulumi preview. In this case, we saw that no resources need to be changed. And so everything is up to date inside our environment. But all of that ran inside the Pulumi service. Now, clicking to deploy is one thing, and being able to come in here and take these actions is really useful. In fact, doing a refresh to understand whether there's been drift on my stack, doing a destroy to go and take care of cleaning up all resources that maybe I don't have the code for anymore. These are all really valuable actions to be able to take here. But what's even more useful is to be able to come into my application and actually make some changes. So for example, if I come over to this index file and just go ahead and edit it, I'll create a new branch and open up a pull request against that branch. And so because this is a pull request that wants to merge into the main branch, and because I set up the main branch as my target before, we'll see that when I create this, if I come back over here, we'll actually see that a deployment started just a few seconds ago. And this deployment was triggered by that GitHub pull request. And we'll see as this runs that it's actually also going to show that a Pulumi preview is going to run. In just a second, we'll see this preview is being started to preview what that PR is going to do. And in this case, it won't show an empty deployment. It'll actually show that it's going to change the contents of that bucket. And so I'll give this just a second to complete. And in fact, this time we can come over here and we should see when it completes, we'll actually see it be posted onto the GitHub PR. There we go. So Pulumi came back and posted that it's going to update this bucket object as part of merging this when we decide to merge this into that main branch. And so now we can go ahead and click merge. I'll just squash and merge. And there we go. We merged that in, which is going to trigger yet another update over here. We'll see that now there's a deployment happening, which is actually going to be the update that actually applies that change to my infrastructure. And so now we get that full GitOps flow just driven off of the GitHub changes. Okay, so let's jump over and look at one more example. So CI is one really important use case for infrastructure as code for Pulumi deployments. But we know that, as Joe mentioned, automation API and being able to embed Pulumi deployments into other software applications is a really important use case for this as well. And so one of the things I want to show is sort of a simple automation API use case, and then how we can go and extend that using Pulumi deployments. And so in this case, we have a simple application built on top of automation API. And this is a Python Flask application. So it's a little web service that lets me to build a self-service provisioning portal. And it uses the Pulumi Automation API as just a Python library. So this is just a normal piece of Python software, but that uses Pulumi's Automation API. I can run this to go see how this works. So I'll open it up. And we see we have just a really simple Pulumi Puss's self-service platform application here, which is a self-service provisioning portal. And I can go ahead and create something like create a website, go here to get started, give it a name, and give it some content. Now, when I hit create on this, if we come back over to our application, we'll actually see that, that what happens is this triggers a Pulumi deployment. Nope. Actually, I'm showing the after version of this. So this is actually now running that deployment, and it's running it inside the Pulumi deploy. And so this is using the Pulumi deployment support. So if I come over here, we'll see that Automation API has been enhanced to be able to use create or select remote stack from with Git source. And so this is actually going to create that stack in the cloud using Pulumi deployments and focusing on the code that lives inside this examples branch. And so now we can use Automation API both to run deployments locally within our software and also to run those deployments inside the cloud with Pulumi deployments. Now I'll just go ahead and cancel this because we won't wait for that whole thing to deploy. But the one last thing I wanted to show about deployments is that all of these capabilities we showed, whether it's the click to deploy, the GitHub push to deploy, or the Automation API support, they all build on top of the same foundation, which is this raw REST API for triggering deployments. And this REST API is available just as one of the APIs on api.pulumi.com, and just makes available this deployments verb on stacks. For any deployment, I can just trigger it using a source context, which is a Git repo, and some details about that Git repo, and an operation context. For example, that I want to run an update and that I want to use these environments variables. And if I run this, we'll see that when I run this curl command, the response is actually that I've kicked off a deployment and I get back the URL. And I can now yet again see this deployment running, but this time just triggered by a simple curl command and a REST API call. And this can be now embedded into all sorts of other use cases. And so, for example, in our deploy demos project, we show off a handful of use cases for what we can build with this, like a drift detection feature that automatically runs refreshes on a timer, or time to live stacks, which we're going to, they're going to self-destruct after a certain number of hours based on a tag that you apply to them, and so many other kinds of use cases that you can build on top of this foundation. So that's a quick tour of the Pulumi service and Pulumi deploy, and I'll hand it back to Joe.
All right, so Pulumi deployments is available as of this morning, so feel free to check it out. In fact, for the first 100 people that give it a try and successfully deploy something, you'll be getting some free swag in exchange for trying it out, and we'd love to hear your feedback as well. What are the sorts of things that work well? What is the sorts of things that you'd like to see maybe improve down the road? So just to recap, you'll see deployments in the SaaS. You'll see this nice new button in the upper right-hand corner when you've enabled deployments for your stack. This rich REST API, we have documentation available now out in the Pulumi documentation that describes all of the new API endpoints and how to use them. Programmatic deployments, you saw Luke both directly go against the REST API if that's just curling an API, or programming against it is preferable, but you can also do remote deployments in the Automation API itself. Now, Git push to deploy, the way that sort of works, you saw that in action, but to configure it, you'll first install the Pulumi GitHub app and then configure it to point at the repo and branch that you want to deploy. You'll put environment variables in there as appropriate, especially if you're using that to manage cloud resources. It needs a way to authenticate from the server to your cloud account, and we have secrets built into that as well for encrypted sensitive information. And then go code away, and as you open pull requests and merge, magic is going to happen. So really exciting features. The team has been really hard at work on this stuff. It's really been magical seeing it all come together, and I hope everybody gives it a try and loves it. And again, if you prefer using Pulumi the same way that you did previously, maintaining your credentials on the client so that the Pulumi service doesn't need to know how to talk to your cloud account, all of that stuff that you just saw is additive to the existing support for existing CI/CD choices, or just running the command line in the traditional way. If you're curious sort of what the architecture behind Pulumi deployments is, you can think of the main difference is where does the compute run for the program. So here's a little diagram just so you have a mental model of this. Previously the Pulumi program always ran wherever the command line ran, or wherever the CI/CD integration runs. So if you're using the Kubernetes operator, the Pulumi engine is running in the context of wherever that is running, which means that any communication from that client to the cloud provider happens between the client and the cloud provider, and the Pulumi service is really orchestrating, state management, concurrency control, identity, things like that through its REST API and hosted service. But what Pulumi deployments brings to the table is, well, a new REST API and a new set of client-side functionality, but more fundamentally on the server, we now have these workflow runners that can actually run Pulumi compute, Pulumi programs, And that's really exciting because it really unlocks not just the initial features that you're seeing on day one, but a long list of exciting functionality that you'll see in the coming months that today you can build on your own, like drift detection and remediation, time bomb stacks, things like that through the REST API, but lays the foundation for a lot of new exciting functionality down the road. So I'm close to wrapping up here. I really appreciate everybody's time today. I wanted to just celebrate, some of the ways that we're seeing customers innovate with Pulumi. I think across a lot of different dimensions, we're seeing just customers taming cloud complexity. And how are they doing that? Well, they're automating a lot more with things like the Automation API. They're empowering developers with guardrails so that the infrastructure platform team can build out their platform, define their best practices and their policies, using things like components and packages, but then turning around and letting developers self-serve some of the infrastructure. Should a developer need to file a ticket to create a serverless function, for example, or would it be better to just empower developers to be self-serve and build some portion of the infrastructure? We find a lot of these customers want to go down that path, and yet the infrastructure team, of course, wants to maintain control over things like virtual private clouds, Kubernetes clusters, and some of the more complicated aspects of the infrastructure that need to be secure, cost-effective, and reliable. But we just hear incredible stories of being able to deploy 10 times faster, reducing the amount of time spent on maintenance by more than 50% in the case of Atlassian, reducing lines of code by 98%. Like, some of these numbers are just mind-blowing. And it's no surprise that people picking Pulumi are way more productive than typical infrastructure as code solutions. And with that, I'd like to invite Larry and Matt to talk a little bit about how Starburst is using Pulumi.
How does Pulumi impact the company beyond just your development team?
Yeah, Pulumi has a pretty big impact beyond just developers. I mean, it's all rooted in developers, but it helps a whole lot with allowing cross-team collaboration. You don't necessarily have the problem that you have with other tools in the space where there's specific subject matter experts that only know how to use that specific tool or write code in that language that tool needs, like HashiCorp config language for Terraform, right? Which allows a broader set of engineering to be able to solve problems, which allows at levels of leadership to be able to make better decisions about like allocating teams, allocating resources to problems, and being able to take advantage of all of the resources you have in your organization. And it also unlocks people who are, say, building product features that need support from infrastructure to self-serve their own needs, which gives them a better work environment, allows them to be engineers and, hack on the things they want to hack on. It allows for more innovation as a result. And that means that we get a lot more potentially great ideas going into the overall planning process. So from the perspective of like planning planning the construction of the product of a company like Galaxy, we've been able to do a lot more with taking advantage of cross-team resources and taking advantage of having engineers be so self-empowered that they just push through problems. They're not waiting on another team to solve a problem for them.
That's awesome. And do these product teams know that Pulumi is behind everything, or does it kind of just work like magic, or maybe just talk through? Yeah,
I think that actually they absolutely do, and they're very comfortable working in the code. So they see in the TypeScript code that we're importing Pulumi. They know that to include that in their PR, that if they need to make an infrastructure change, they just make a change right there in the Pulumi code, get their PR out there. And we still have somebody from the infrastructure teams kind of like take a look because we're pretty new. with Pulumi, but they know exactly what it is, and they have no problems making the changes themselves.
Matt is an engineer at Starburst, and it's been a great partnership helping them build their cloud platform and their SaaS product. And so, really awesome to hear, from an end user's own words why they love Pulumi. And I think, just to summarize, what we're seeing, why do people love Pulumi? You heard Matt talk about this. It's for the entire team. It's not, we often hear that there's a couple Terraform experts over there that that understand everything, but maybe the whole team isn't empowered or don't understand how the infrastructure works. And really, with Pulumi, developers can get more involved, but infrastructure teams can also up-level their game and have great tools that work at scale and with modern cloud complexity. It's a standard workflow for any cloud, so public, private, or hybrid, rather than having one tool for AWS, one tool for Azure, and trying to bash script everything together with kube control in the mix somehow. It's one workflow that works for any cloud. You 10x your productivity. You saw that Automation API users are able to manage 10 times more infrastructure than typical infrastructure as code scenarios. You get real sharing and reuse so that we're not copy and pasting scripts. You can use real software engineering practices to share and reuse those best practices across the team. You can embrace cloud native architectures, from containers to serverless to managed services and everything in between, and really scale from very simple cases to the most complex and ship faster with confidence, and do in hours what used to take weeks to get done. And we love the community. Thank you to everybody here that's joined us today. Really, you are why we do what we do. This is one of my favorite tweets of all time. Nino says, something special comes along sometimes that makes you feel like you have superpowers, enables you to do more in less time. And Pulumi is that special thing. And I think that just summarizes, everything very succinctly and in a nice, heartwarming way. So with that, we're done with the keynote. So thank you again. I hope you enjoyed what you saw. Definitely check out some of the new features. Everything's up on Pulumi.com. Eager to hear what you think about Pulumi deployments. We've got a ton in store for you today. Next up is a deep dive into the new features with Megan and Bryce, largely focused around Pulumi deployments. So you get to see some really exciting scenarios that we alluded to. We'll see infrastructure software, taking some of the core infrastructure as code principles and using them at scale to tame complexity with Luke and Mitch. We're then going to have a really exciting segment, which I can't wait for, talking about some of the folks from the Pulumi community, some of our customers. Dennis at Panther is going to talk about how they went from CloudFormation to Pulumi at a very large scale and got tons of engineering and performance wins as a result. Dan at Altana AI is going to talk about creating business logic interfaces with Pulumi's Automation API, really taking that Automation API and weaving it into the fabric of everything that they're doing. Jeff at Fauna is going to talk about how the Fauna product is built on top of Pulumi at scale and how they built out a global data platform and their own SaaS product using infrastructure as code. Colin at Dutchy is going to talk about how they took Pulumi and Confluent Cloud and kind of married those together to enable Kafka at scale within their organization. We're then going to come back to main stage and see Automation API under the hood with Evan and Casey, see how the nuts and bolts of how all that works. And then I'll be back for some closing remarks at 11:50 a.m. Pacific time. I also just wanted to remind folks that we've got some great workshops going on both today and tomorrow, from Pulumi 101 today, building containers on Azure, Kubernetes serverless, and with Ringo tomorrow, seeing how to build shared code with Pulumi packages and abstractions. And so these are free workshops. Feel free to join in, get some hands-on coding time, and learn some of these concepts firsthand with some of the amazing leaders on the Pulumi team. I do want to thank our partners that help make this event today possible: AWS, Microsoft, and Google Cloud in particular. From there, thank you so much, and have a fun time. And I'll see you back in a few hours.